Today we're talking about systems of linear inequalities. So we've talked about how to graph a linear inequality in two variables, where you have the shading areas in the dashed line versus the solid line. We also worked on systems of linear equations, where we looked for the common solution intersection point. So now we're going to look about how to do a system that has two linear inequalities. So a linear inequality system is a set of two or more linear inequalities in the same variable. So obviously they both have to be the same two variables to do the system. So here is an example right here. So these two inequalities, if they are a system, are working together. So the solution of a system of linear inequalities is an ordered pair that is a solution for both inequalities in the system. And again, it has to fit both. So let's first start by checking some solutions to some inequalities systems. So 3, 5. Is that a solution? So again, it's just a matter of plugging it in. So 5 and 3. If I just plug it into the first one, y is less than 2x. 5, is that less than 6? Yes. But remember, we also need it to work for the second inequality. So 5 is greater than or equal to 3 plus 1. So 5 is greater than or equal to 4. Yes. So that would definitely be a solution to that system. On the second one, if I plug in 0 for the y, is it less than 2 times negative 2? Well, right away, the answer is no. And then just to verify, if I plug it into the other one, I would get 0 is greater than or equal to negative 1. So this one is fine. That's true. But this one on the left is not true. So if one of them is not true, then it is not a solution. Okay, so to be a solution, it has to satisfy both inequalities. So now we want to graph one of these. So the graph of a system is the graph of both the solutions of the system. So first, we want to graph each inequality in the same coordinate plane, including its shading. Then we're going to find the intersection or overlap of the half planes that are solutions. So it still is the intersection where they cross each other, but it's the overlap that we're really looking for. So the intersection is going to be the solution to our inequality system. And then we always put like an S in that overlapping section because it gets a little bit cloudy. So as you can see here, we have a lot of stuff happening in here, but this little area right here, which is the purple, this would be the overlapping part that is the solution set to the system of inequalities. So let's just kind of do one out from start to finish so you can see what it looks like. So here we have a system. So we first have to make our graphs, and we have to come up with our shadings, and then we can worry about where our solution set is first. So I'll do the red for y is less than or equal to 3. So remember what we talked about in the previous lesson. To graph the boundary first, think of it as y equals 3. Then, because it's in less than or equal to, it will be a solid line. So y is less than 3 is going to be a horizontal line right there at 3. To test a point, if I was to test 0, 0, 0, is it less than or equal to 3? The answer is yes. So I'm going to shade downward. That would be the graph of the first one. So now moving on to the second one, and I'll do this one in blue. Y is greater than x plus 2. So it's in slope-intercept, so I'm just going to leave it in slope-intercept form. Greater than without the or equal to means it's going to be a dashed line. So I would do my y-intercept is 2. My slope is a 1. So something like that. But then notice we're going to do the dashed line coming down here to show that boundary. Now I think 0, 0 is still off of my boundary enough that I can test that point. So if I do 0 is greater than 0 plus 2, 0 is greater than 2, which is not true. So that would tell me that my shading would go up this way. So now, when I'm looking for the overlapping or intersections of the shading, it's going to be sitting right in here. That would be part of that boundary, part of that boundary. I'm going to put this big S right in here because it's sitting right there. You can see that the blue and the red are overlapping. And that would be the solution area for this system of inequalities. So again, we have another one that we want to figure out our solution set. So for these two, what I might do is turn these both, because I don't think they're great standard forms. I might turn these two into slope-intercept form by subtracting that 2x to both sides to making this my new inequalities for the system. So like we did in the previous one, I'm going to do this first one in red. If I think of it as y equals negative 2x minus 1, there's my y-intercept of a negative 1. This would be a dashed line because it has just the less than without the or equal to. If I was to test 0, 0, it's close, but I can see that it's not on my line. So 0 is less than negative 2 times 0 minus 1. 0 is less than negative 1. Not true. Which means I would be shading this direction. So then the second one I'll do in blue. So again, think of it as an equal sign, but think that it's also going to be dashed. I'm going to go up to 3, down 2 and forward 1, down 2 and forward 1. And then if I was to test 0, 0 here, I get 0 is greater than 3. That's not true, which means I'm going to shade off in this direction. So what do I see here? I see my solutions for the red one never meet solutions to the blue one. So because there's no overlapping area, this system has no solution. So a couple ways that I could see that. Clearly, when I look at these two in slope-intercept form, same slope, remember that means that the lines will be parallel if these two y-intercepts are not the same. So I have two boundaries that are parallel to each other, so they're never going to meet or cross. That kind of tells me something. But then because the shading is both going away from itself, that's why there's no overlapping parts. So we could definitely have a different set of solutions depending on the shading parts. So don't think, well, just because they're parallel lines, there's no solution. It does depend on the shading, because I could definitely have different inequality symbols with these same two equations that would make them have different answers. But in this case, they don't meet, so there is no solution. So now we want to write some equations based on what we're looking at for the graph. So this graph is not as cluttered, because basically what they're doing here is they're just taking out all the other parts and they're telling us that's the solution set. So how do I do that? Well, I want to think about a couple of things. So looking at this first equation right here, I want to write that equation and then turn it into the inequality that would produce that. So what I would say is focus on it, the boundary only, as an equals sign. So if I had looked at it, my B is crossing at 0, 0. My M, if I went from 0, 0 up 2 and right 2, I hit the line again. So that's a 1 slope. So my equation for the boundary only is y equals x plus 0, which really is just y equals x. Now, it's not an equals because it's a dashed line, and it's definitely not just an equation because it has a shading part. So then I have to think, what would produce the shading to make that work? Well, it's kind of going down and to the left, to the right, sorry. So I'm going to say that this is less than x. So let's test it. So let me just grab a point, like right here, 2, 1. So if I test 2, 1, 1 is less than 2, if I plugged it into my equation, that is true. So that would probably tell me I have the first one correct. So then my second one, just going to show you this is the one I'm looking at. So this is a horizontal line. It's a solid line, so I know it has the or equal to part. The horizontal lines I know are y, and then there's no x's, but where it crosses is at -2. Now in this case, all the points that go upward. So let me test that same 2, 1 point. If I was to test 2, 1, there's no place to put the x, but the 1 can go in for the y. Is 1 greater than -2? Yes. So there's your system right there. Y is less than x, and y is greater than or equal to produce the solid line, -2. So let's try the next one. So again, we'll do the red for this first one. Now this time I know that that's a vertical line, so that's going to be x equals 3, but it's not an equals because it's an inequality. We definitely have the or equal to because it's a solid line. If I was to plug in this 0, 0 right here, and let's test it. If I plug in 0 and a 3, can't be greater than, it would have to be less than, right? So that's going to be the less than or equal to. And then on the second one, we'll do that one in, whoop, it's not really there, it's a little bit lower. Again, my y-intercept is at -1, and I see a slope of 2/3. So then I got to think of my shading. It's a dashed line, so I don't have anything that's going to be solid. But I want to think of, is it greater than or less than? So if I use that 0, 0, same one because it's clearly off that line too, I would have 2/3 times 0 minus 1. I would get 0 is 0 minus 1 and 0 is greater than -1. So that means it's going to be greater than here as well. That would be my answer to this one. They take some time to get kind of used to it, but once you get better at doing these, write the equation first of the boundary, then figure out your greater than or less than from the shading. So here we are. We first have to write the system, which is always a challenge, and then we're going to graph it to figure out how to answer the question at the bottom: how much time can we spend at each location? So you have at most, so let's start thinking about this first one. At most, 8 hours to spend at the mall and the beach. I'm going to call the mall X and the beach Y. Then you want to spend at least 2 hours at the mall and more than 4 hours at the beach. So we got a couple of things going on here. We actually have 3 inequalities to focus on. So let's just do them one at a time. Let's focus on our hours at the mall and the beach. So I have some number of mall time plus some number of beach time. At most 8 hours. So then when I look at my next one, we'll do that one in blue. My time at the mall is at least, so 2 or more. And then the final one we'll do in green. My beach time is more than 4. So we actually have 3 different ones we need to put together. So what I'm going to do is we're not going to do all 4 quadrants because we can't have negative time anywhere. And we're going to have our mall time is our x-axis. Beach time is our y-axis. And then we just have to start graphing. So we're going to go with a 1 scale on both. So if I focus on that first one, it's in standard form. And if I was to plug in 0, 0 to help me find my intercepts, that'll be easy. So when the x goes in as a 0, the y is an 8. When the y goes in as 0, the x is an 8. So basically, the easiest one to do is just keep it in standard form. So 0, 8, 8, 0. Then, because it has the or equal to, it's going to be a solid line. There's the boundary. Now, if I was to test the point 0, 0, 0 plus 0 is 0, that is less than 8. So because of that, this would be the complete graph of just the first inequality. Then let's move on to the second one. So x is greater than or equal to 2. So we know it's going to be a solid line. We also know that it's a vertical line at the 2. So there is my vertical line at 2. Now it's greater than 2. So thinking about it, any x that's greater would have to be going in this direction. And again, if I was to test my point 0, 0, the 0 going in for the x is not greater than 2, so I would be shading this right side. And then the last one, y is greater than 4. So again, that's going to be a horizontal line with a dashed line at 4. So it would look like this. First, greater than would be going up, and I'm going to try to do a little bit of a different pattern there. That would be the graph of that one. So what we're looking at is this area right here. And then obviously this is the entire area we're talking about. That is our completely overlapped, all 3 areas for our solution. So then, how much time can you spend at each location? Well, It's kind of hard to give all the times because there's a lot of times there. But what we're thinking about is how much time can I spend at the beach? How much time can I spend at the mall? So any of those ordered pairs in there would actually be a way to solve this answer. So I'm just going to write, you can spend 3 hours at the mall, 5 hours at the beach. And obviously that's not one of the only answers. If I pick that point, it's sitting right there. That one is satisfying all three. So 3 plus 5 is less than or equal to 8. X has to be more than 2. So my time at the mall has to be more than 2. 3 is more than 2. The Y has to be greater than 4. My beach time is 5, which is greater than 4. So this would be a combination that would work. It's not the only combination. You could definitely still do 3 hours at the mall and 4.5 hours at the beach, and you would fall more inside that space as well. So hopefully this is okay. We are just be careful when you're drawing your boundaries. Look for that or equal to part. If it's a dashed line, that means that it's just greater than or less than. Be careful on your shading so that you can see your overlapping shading. That's probably the hardest part to do. Think about different diagonals going against each other, thinking about different shapes as you go against each other. If you can do different colors, it's even easier. If you have any kind of questions, please feel free to talk to me when I see you in class.